In this video, we will be doing a high-level breakdown of each of the demos from the team behind the ACE framework. In each demo, the focus will be on how the project is set up, how the ACE cycle is started, and how the ACE cycle operates. If you are not aware of what the ACE framework is, you should check out David Shapiro's video on the ACE framework. Moving on to the first project, ACE-AF, the setup of the project revolves around the ACE module, the chat module, the ChromaDB, and the chat UI. Inside of the ACE module is composed of multiple instances of other modules. It first instantiates all the layers, where each layer inherits from the ACE layer, and the ACE layer uses the AgentForge as the main driving force in prompt generation. Next, the ACE module sets up a Flask app with only the bot endpoint that allows for messages to be sent to the ACE framework. Now, the chat module is what is used by the agent layer to empathize and reflect about what should be said about the messages sent in. It does so by using a combination of the thought, generate, and reflect agent. Now, each agent inherits from the AgentForge agents, once again, using it as the main driving force for the prompt generation. Now, the ChromaDB is the vector DB of choice that is used to store the bus messages. And finally, the chat UI, not to be confused with the chat module, acts as the medium that allows for the user to input messages into the ACE framework and for the ACE framework to output to the user. Moving on to how the ACE cycle is started up, there are two ways that the ACE cycle can be initiated. Either when the ACE module gets started up, or when the user interacts with the chat app. When the ACE module gets started up, it triggers the input update event in the top aspirational layer, which then starts the ACE cycle. Now, when the user sends a message to the chat UI, the message gets routed to the bot endpoint. Then the bot endpoint directs the message to the agent layer, where the agent layer then goes through the ACE cycle. Now, once the ACE cycle completes, it then responds back to the initial user message. Moving on to how the ACE cycle operates. It first starts by loading the north and south bus messages from ChromaDB bus collection. Then using those messages as context, it then generates a message by calling the AgentForge to run, which then uses ChatGPT to generate a message. Then it parses the output into the respective north and south bus messages and then loads them into the bus collection in ChromaDB. Then it triggers the next layer, thus continuing the cycle. Moving on, the next project is the Hello Layers project. The setup of this project revolves around the buses, the layer, the system integrity, and the resource module. The resource module is the base class that the other modules inherit from. Inside the buses module, it establishes all of the queues and exchanges for the buses between each layer and the system integrity queue for each layer. In the resource module, it subscribes to the system integrity queue, where the callback for this queue fetches the function from the command and calls the function from the class and inherits the resource module. Now in the layer module, it subscribes to the bus queue, where the callback for this queue publishes the messages to the consumer local queue. In the system integrity module, it subscribes to the system integrity queue, where the callback for this queue starts the ACE cycle once all the checks have been passed. All the queues and exchanges are powered by RabbitMQ, and all the modules and services are coordinated by Docker Compose. Moving on to how the ACE cycle is started, once all of the layers and modules have been established and all the checks have been passed, the system integrity module fires off a message to the system integrity queue that the top aspirational layer is subscribed to. The callback then triggers, which then uses the message as context and generates a message from ChatGPT, and then parses the output into the respective north and south bus messages and then sends them out to the respective bus queues. Once sent to the bus queues, the messages then get routed to the consumer local queue for the next layers to process, which then goes into how the ACE cycle operates. The ACE cycle operation is very similar to what was just described previously, but with the exception that instead of the message being sent directly to the bus queues, it first gets sent to the publisher local queues, which then gets sent to the north and south bus queues for the next layers to process, thus wrapping up how the Hello Layers project operates. The next project is IACE UI. The project is set up by using RabbitMQ, PostgreSDB, an API, and Docker Compose to coordinate everything. RabbitMQ is responsible for handling the delivery of the bus messages between each layer. As per usual, every layer will have a north and south bus, the north bus being responsible for the data and the south bus being responsible for the controls. Now in this scenario, every layer will be subscribed to a control bus to receive messages from the upper layers and to a data bus to receive messages from the lower layers. On the flip side, each layer will also publish messages onto the control bus for the lower layers and will publish messages to the data bus for the upper layers, thus making each layer responsible for 4 queues in total. Now in the PostgreSDB, the main data that it stores are the identity, reasoning, ancestral, control, and data prompts. The identity, reasoning, and ancestral prompts will be used for the system messages, and the control and data prompts will be used as rules for ChatGPT to abide by. Now in the API, the main endpoints are either the CRUD endpoints or is the mission endpoint, which is responsible for starting the ACE cycle. Now for how the ACE cycle is started. First, the Svelte front end is started up. This provides a UI for the user to interact with where they can input the identity, reasoning, ancestral, control, and data prompts into Postgres, thus populating the DB. Here the user can experiment with the prompt engineering and see the results through the UI. Once the DB has been populated, the user fills out a mission for the ACE framework and then triggers the mission endpoint, which then sends the mission statement to the control bus queue for the top aspirational layer, thus starting the ACE cycle. Which brings us to the last part of this project, the ACE cycle. Starting from the control bus queue for the aspirational layer, the queue receives a message from the mission endpoint, which then redirects to the aspirational layer. Once the aspirational layer receives a message, using the message as context in the identity, reasoning, and ancestral prompts as the system messages, and then prompts ChatGPT to generate a message to reason about the message received. Now with the reasoning generated, then uses the reasoning and message along with the previous prompts used to prompt ChatGPT twice to generate messages to put onto the control and data buses respectively. Now with the control and data bus messages ready, it then sends the messages to the data and control bus queues for the next layers to be triggered, thus continuing the cycle. For all the other layers, the process is exactly the same with the exception that the messages can be both fetched and published to either the control or data bus message queues. Now moving on to the next project, Python Flask Easy. This project is the most straightforward and the most unique in terms of how it operates. First, we'll take a look at how the project is set up. The project is composed of 3 parts, the layer modules, the Flask app, and the logs. Starting with the layer modules, every layer operates the exact same except for the top aspirational layer. Layers 2 through 6 will be responsible for fetching, generating, and posting messages to both the north and south buses. But for the aspirational layer, it will only be responsible for fetching messages from the north bus and only posting messages to the south bus. Now the Flask app contains 2 endpoints, the get messages and the post messages. Get messages is responsible for fetching messages from the buses, and post messages is responsible for publishing messages to the buses. Now the logs is the folder that holds all the messages sent to both the north and south buses. To determine which log messages came from which layers, they are denoted in the file name containing the time it was published, which bus it was directed to, and which layer it came from. Moving on to how the ACE cycle is started, the unique part here is that the layer modules act independently of each other, and that they do not need to rely on a trigger or an event to happen externally from the other layers to operate. Instead, once a layer is started, it launches into an infinite loop of fetching, generating, and posting messages every 5 seconds. On to the last part, how the ACE cycle operates. When the ACE cycle starts, it calls the get messages endpoint twice to get the messages from the logs, once for the north messages and once for the south messages. Then using the messages fetched as context, it then prompts ChatGPT to generate the next set of messages. Then the output is parsed into the north and south bus messages. Then finally, it calls the post messages endpoint when the messages then get sent to the logs folder. Finally, onto the last project, Stacy. Starting with the project setup, the 3 main parts are the UI, the API, and the ACE system. The UI can either take on the form of a simple web chat app or as a Discord bot, both of which gives a medium for discussion to happen between the user and the ACE framework. Now for the API, the main endpoints are the chat, publish message, and bus endpoints. The chat endpoint receives input from the user and outputs the generated message from the ACE framework. The publish message endpoint receives a message and publishes it onto the corresponding bus. And the bus endpoint fetches all the messages from either the north or south bus. Now the ACE system is composed of multiple modules. Inside the ACE system, it instantiates all of the layers and both the north and south bus. Each layer inherits from the ACE layer module, which provides the base functionality for all the layers. The bus module contains a message log and a subscriber list to keep track of which layers should be receiving which messages. Now after some time, the team behind Stacy found that operating with just the agent layer yielded better results than using multiple layers for their use case, and came to the conclusion that simple is better, which led to the following setup. Due to the unique nature of this project, we'll just be going over how the ACE cycle operates. It all starts with the UI, where the user inputs the message they want sent. From here, the message gets sent to the chat endpoint, which then sends a message to the agent layer. Using the message as context, the agent layer then prompts ChatGPT for response to the message. Now with the generated response, it passes it back to the UI for the user to see, thus finally wrapping up the final project. I hope you enjoyed this breakdown of all the demos from the ACE framework, and that inspires you to build your own version of ACE. If you like this video, please do the usual, such as like, comment, and subscribe. If you have any critiques about the video or suggestions on what I can do to make this better next time, please let me know down in the comments. All right, have a great day.